Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day to each and everyone. So, Alhamdulillah, this will be our second lectures now for this final coverage for our subject ES12. Okay, so I think we have only one remaining lectures to be finished for us to be able to totally have our final lectures in this semester. Okay, so um okay, so just refer on our first lecture until the last one, no, for you to be able uh, to fully accomplish the required topics that we have to include on our uh, final exams. Okay, so without further ado, let's begin on our discussion for these topics. No, our topics for today is a complex numbers and function of a complex differentiation. Okay, so when we talk about complex number, it means that um, no it actually it totally different from, or it totally different from the concept of real numbers, no, kasi dito sa complex number we have a real number and imaginary number. It means that it is the combination of two. Okay, so it has also an important application, just like differentiation, um, just like categorizing the three fundamental application of complex numbers. Okay, so let's begin. Okay, we have here the complex numbers and their geometric representation. Okay, so in here sa topic na to, we are representing the complex number, or we are representing the component of the complex number with x and y components. Okay, um x is a real number and y is the imaginary number. Okay, um, it has actually a different application, no, but in here um, uh, we uh, applied, no, the both application of this one in one application. Okay, so meron tayong imaginary number of the z, no, that combination of real and imaginary actually uh, is signifies or categorized by one variables, which is z. Okay, we have z is equals to x and y. Okay? So, for example, dito sa equation number 1, we have I, or imaginary number, is equals to 0, 1. Why? Because in here, sa I natin, sa equation number 1 natin, wala tayong real number. Okay? Wala tayong real numbers, only imaginary number. So, that's why I is equivalent to a combination of 0 and 1. Okay? So, yan. Dito sa equation 2 naman natin, we have z1 plus z2 is equals to x1 y1 plus x2 y2, no? So since imaginary and real number are distinct numbers, no, they cannot be combined to each other, to each and every one, no. We have to add them, no, um, with the same quantities. Okay, so for example, yung x1 natin, or yung real numbers ng first complex number natin, should be added with our real number, or the second imaginary numbers. Okay, or the second complex number. Okay, same with our imaginary numbers. So we have here the application, or the rules for multiplying two complex numbers. For example, meron tayong z1 that is represented by x1 and y1, and z2 that is also represented by x2 and y2. If we have to multiply that one, we have here x1 times x2 minus y1 times y2. Okay, for the real numbers, and x1 y2 naman plus x2 y1 for the imaginary numbers. Now, so if you have to uh, step by step, no, to if you have if you have to multiply this one step by steps, you notice that you will notice that the result is this one, x1 x2 minus y1 y2. Okay, for the real numbers, and x1 y1 plus x2 y1 for the imaginary numbers. Okay, so we can also rewrite x1 or x0 with x lang, no? Bakit? Kasi same with our dito sa kabilang sa equation number 1, we have yung I natin, pwede natin siyang i-represent with 0 and 1. Okay, a combination of real and imaginary. So dito naman, if the complex numbers is only a real numbers, is composes of only real numbers, we can actually represent that one by x0 lang, okay, or x lang. Okay? And similarly naman, if yung complex number natin is 0 yung kanyang real numbers, and then it can be represented by I, Y lang, okay, or complex numbers, or I mean an imaginary number, okay. So yun, because I, Y is represented by this application, okay. We have here, kung titingnan natin yung kuan dito, itong computation dito, yung IY natin, pinakita lang niya rito that our IY should be represented by 0Y by using this calculation here. Okay? So, okay. So, if x is equals to 0, then z is equals to iy, and is called a pure imaginary. We can also represent that one by I squared is equals to negative 1. Or I squared is equals to I times I, which is equals to 0, 1, multiplied by 0, 1. Or, if we have to multiply that one manually, we have here the final result is negative 1 only. Okay? So, yun yung kuan natin. Yun yung magiging result natin for multiplying the two complex numbers that is being involved here. Okay? So, we have here an example. Okay? I think this is a very representable examples of that discussion. No? So, you may just have to read that one and refer to it regarding the application of addition of complex numbers. Okay? So, yun. So, dito tayo sa subtraction and division. Okay? Yung kanina is addition and multiplication. Dito naman is subtraction and division of the complex number. Okay? So, kung meron tayong dalawang complex number, which is represented by x1 and y1 and x2 and y2, okay? They can be subtracted with separately subtracting the real numbers and imaginary numbers. Okay? Just like as we have see here sa equation number 6, now we have z1 minus z2 is equals to x1 minus x2 plus I y1 minus y2. Okay? So yan yung pag-subtract ng dalawang complex number natin. Now, how about the division? For the division naman, medyo mahirap to siya dito, no? Kasi bakit? It's not like a dividing the two real numbers, no? Na nakasanayan na natin, no? In here, uh, since we are talking about a complex number, it quite different from the calculation for real numbers. So kung makikita natin dito, kung meron tayong dalawang complex numbers which is represented by x1 plus iy1 and x2 plus iy2, if you have to divide that two complex numbers, okay, meron pa tayong calculation for us to be able to arrive to the final answers, no? So as you can see here sa equation number 7, the final answer is this one here. Okay? Which is this first term here is the real number, and the second term here is the imaginary numbers. No? So, the first term, which is the real numbers, is composed of this one. We have x1, x2, plus y1, y2 over x2 squared plus y2 squared. So, yun. Yun yung final answers. Then for imaginary numbers naman, we have x2 y1 minus x1 y2 over x2 squared plus y2 squared. Okay? So yun. So, and of course, we have here an example. So you may just have to read that one using this method here that is being represented. Okay? So dito tayo sa complex plane. Okay? So same as real numbers, we can also represent a complex number with we can also represent complex number using complex plane. Kung meron tayong tinatawag na rectangular plane sa real numbers natin, meron din tayong tinatawag na complex plane dito sa complex number natin. Okay, so if meron tayong complex number that is represented by x plus I, y, that complex number can be represented as a point or as a line that is being drawn from the origin papunta doon sa point that is represented by that complex number. As you can see here sa graph na to, no? Itong complex number natin which is z is equals to x plus iy, okay, is drawn from the origin of this complex plane papunta sa point where it represented by this complex number. Okay? So, yun. So, may mga cases where there will be a 3 involving um, dimensional dimensional axis of complex number, but we are not focused on that one, no, since our focus in this case is only for the two real numbers, no, that is being represented by the uh, real and imaginary numbers. Okay, so yun. So in here sa, no, for example, this figure 319, meron tayong complex number which is 4 minus 3i that is represented by this point, no. Kung makikita natin dito, this figure here represented the complex number which is 4 minus 3i. Okay, since yung 3i natin negative, since yung kuha natin is nandito siya sa 3i, negative 3i, then yung real number natin is nandito siya sa 4. So kung mapapansin nyo, itong axis na to is yan yung real numbers natin. Yung y, itong axis na to which is y, is yan yung imaginary numbers natin. Okay? So yun. Dito naman sa dalawang figure na to, ito yung pag-add and pag-subtract ng dalawang complex number. Ito yung representation niya using a complex plane. Okay? So, kung makikita natin dito for Z1 and Z2, if we have to add that one, meron tayong, we have just to use the parallelogram method, no, that we have already learned from our physics, no. For example, meron tayong dalawang vector or dalawang complex number to be added. So, yung isa is i-add natin dito. So, ito yung result natin. Okay? So, in short, a complex number can also be said as a vector, no? It means that meron siyang direction. Okay? So, yun. So, it means that if we have to add them, we have to consider the direction it represented. Okay? So, okay. So, if you have any question about these topics, you may just have to ask it to me. Okay? So, meron dito naman tayo sa complex number or complex conjugate number, no? When you say complex conjugate, it these are the two complex numbers in which they represent the other complex number in a conjugate way. What do you mean by conjugate? Yung imaginary numbers natin is ika-contradict natin doon sa imaginary numbers ng isa. For example, this dalawang complex number here, itong z is equals to x plus iy is conjugate by this complex number, another complex number here which is x minus iy. Okay? And using a complex plane, it can be represented by this one here, no. You may just have to refer the point, no, with respect to the axis or x-axis or the real axis of the complex plane, since it is just a uh, conjugate, no, or same real numbers. As you can see here, they have just same real numbers which is 5, but it has a different imaginary numbers. Okay, so yan. So also read these examples about that one. Okay, so dito tayo sa number 2, we have the polar form of complex numbers. So same as real numbers, we can also represent a complex number with polar form. Okay, so we have here, yung x natin can be represented as r cosine theta, and then yung y natin can also be represented by r sine theta. where theta is the angle that is being formed by the vector representing that complex number with the x-axis. Okay? So, yun yung theta natin. For example, itong vector na to, which is representing the complex number na 4 minus 2i, yung theta natin is makikita natin siya dito. Okay? Okay? Or yung angle between this vector na to dito sa x-axis. Okay? So, yun yung theta. Okay. So, and then for the magnitude, okay, we can just use the Pythagorean theorem. Okay, Pythagorean theorem, which is this one. Okay? So, yun. Okay, so basahin na lang natin siya. So, example, basahin na lang din natin to siya. So, dito tayo sa multiplication of and division of the polar form. Okay? So, if we have a complex number that is expressed in terms of polar form, we can actually multiply them by using this method here. For example, meron tayong z1 is equals to r1 cosine of theta 1 plus I sine of theta 1, and z2 is equals to r2 cosine of theta 2 plus I sine of theta 2. We can actually multiply that one as this, no? As this method here. Okay? Dito, ito. Okay? Or kumbaga same lang doon sa complex calculation, but in here we are talking about a polar, okay, in polar coordinates, not it is no longer in complex form. Okay, so yun. So dito siya nakagamit tayo rito ng identity. Okay, itong part na to rito, kaya naging cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. Okay, so it means that z1 from this equation number 7, we can say that absolute value of z1 and z2 is just equal to the multiplication of the absolute value of the individual. Okay? So yun yung from this equation number 7, we have we can derive this equation number 8. Okay? And same for division. Okay, we have absolute value of the division of z1 over z2 is equals to absolute value of individual z1 individual divided by the other absolute. Okay, so yun. So meron tayong examples dito, paki-refer na lang din, no? So dito tayo sa De Moivre's formula. Actually, this De Moivre's formula is an application or the characteristic of multiplying a complex number, no, that we have already noticed, no? Ito raw yung equation number 13, in which kung meron tayong complex number that is being raised to some constant, for example, itong z to the power of n natin, we can represent that complex number by using this one. We have it is equals to r to the power of n multiplied by cosine of n theta plus I sine of n theta. Okay? So yan daw yun siya. Or uh, or eliminating this z to the power of n at saka yung r to the power of n, we can say that cosine of theta plus I sine of theta raised to the power of n, kasi doon man yan nanggaling yung equation number 13 na yan, is equals to cosine of theta n plus I of sine theta n. Okay? So yun yung De Moivre's formula. So yung De Moivre's formula na yan is marami yan siyang application in a complex number. Okay? So yun. So pakibasahin na lang natin yun siya. Ito namang roots na to, this is just the roots of complex number that is being raised to some numbers. Okay? And basahin na lang din natin yun siya. Ito yung mga derivation ng formula. So ito yung graph ng complex number that is being raised to some value. Okay? Parang nagfo-form siya ng circle. Okay? So yun. Basahin na lang din natin siya. Okay? So meron tayo ditong yung meron pala akong hindi na-discuss dito about the argument. Yung argument kasi is dalawa yan siya. Meron tayong specific argument, or that is just the argument of a one value only. It only represent one graph, no, sa complex plane natin. But yung meron din tayong tinatawag na principal argument, no, or yung tinatawag nating general one. Okay, it means that it only represent one complex number but with a different references. Bakit? Kasi yung isa, for example, kung meron tayong um, complex number, just like for example this one, no? Kung meron tayong complex number na ganito, itong complex number na to, pwede natin siyang i-represent as paikutin natin siya dito sa complex number, complex plane, then pabalikin natin siya rito. Okay? So, kumbaga, equal pa rin yun siya. Same representation pa rin siya. But, ang kwan lang, ang consequences lang na nangyari is, umikot muna siya ng 360 degrees bago siya pumunta rito sa P. Which is the same pa rin naman sa previous. Okay? So, yun yung general, kumbaga, no? Maraming representation for one complex only. Okay? So, yun yung tinatawag na principal argument. Okay? So, yun. So, if you have any question about these topics, you may just have to ask it to me. This would be included on our prelims, for our final exams. Okay? So, that's all. Assalamu alaikum warahmatullahi ta'ala wabarakatuh.